Hello, dear students. This is the video lesson 1 for Introduction to Statistics. This is going to be a 15-minute video lesson. So let's begin. Okay. Well, the main question one may ask is, what is statistics? We probably heard this term many times already. But the objective of our lessons is to really learn the some basic statistics and their applications, and to prepare you for the next lessons and for any applications you may do in projects like STEAM projects, etc. Of course, what is statistics is one way to put it is that it is the universal language of the sciences, in the sense that statistics is used by many different sciences in analyzing and presenting results or making conclusions, etc. Of course, a careful use of statistical methods will enable anyone to accurately describe the findings of scientific research, make decisions using the findings and using the analysis, and of course, use data, use statistics to make estimations. Very important. Statistics involve, of course, numbers, subjects, and the use of these numbers. The field of statistics can be roughly divided into two main areas: the descriptive and inferential. Descriptive is really what we do with the numbers and we analyze them, etc. And then, of course, inferential is to use the analysis of the numbers in order to make decisions, predictions, and so forth. So let's go to the next slide. Some notes. So one definition of statistics that you can find in several books is that it is the science of collecting, classifying, presenting, and interpreting numerical data. So this includes both descriptive and inferential. The use of statistics, there are many examples, of course, but one simple one applied to your case, and you imagine the test results you get usually, and of course, you can use these test results to compute averages, the average test, to see if your score is above or below the average, or find the average score of female students or male students, etc. So you can do this easily with the simple example of the test results. In science and data, results from experiments must be collected and analyzed. So, as I mentioned earlier, from experiments in science, whether this is chemistry, biology, etc. The recent pandemic, of course, we saw many statistical results. So statistics is used everywhere. In business, current past data can be used to make predictions. I can give a quick example of a restaurant owner and collecting information about the menu orders of his customers. And then after a few months, he can make decisions of what is most popular part of the menu and what is not popular, to delete it from the menu, etc., and make decisions, or sometimes preferences, depending on whether it is summer or winter. He can make decisions if he keeps or if she keeps data to make changes, improvements in his restaurant menu. Let's say now let's discuss now some other definitions. Some language we'll be using, like the random sample. A sample is a subset of another population. So when the population, the sample could have different logic. If we are investigating a full city, let's say the city of Limassol in Cyprus, then all citizens of the city is a population. If we take any part of that city, 500 citizens, 1,000 citizens, then this is a sample. And sometimes I can use this sample to make estimations for the whole population, provided that my sample is a good sample. Good sample means has similar characteristics to the population. If the population is 55% female, then my sample has to have a percentage close to 55. If my sample, let's say 500 or 1,000, is 80% female, it means it's not a good sample because it doesn't follow the characteristics of the population. sometimes we need to keep track and control the age characteristics. For example, if 20% of the population of the city is people between the ages of 20 30, then I have to try to control this in a stratified sample, as we say, in order to keep the percentage of people between 20 and 30 more or less in the same in the same amount as the population, to have it also in the sample. So these are sampling techniques and sampling quality. So we will discuss this again, of course. Some other thing you need to know is continuous and discrete variables. Continuous is when we work with real numbers, like measuring the weight according to your how good scale you have. You may have decimal numbers with accuracy. So this is like a continuous, but discrete when you counting people, when you counting animals, when you counting houses. You cannot have 3.5 people, or you cannot have 5.7 houses, for example. So that would be discrete variable, as we say. Measurements, of course, we can have data from grades, weights, and scores, and categorical data when this is sorted in groups, and of course when you have larger, smaller, etc. It's categorical. Independent versus dependent, when something is changing and gets values from your investigation, then it's independent variable. When it affects other variables that we cannot control, then those are dependent variables. Let me go to the next slide. We should know what is a nominal scale. Labeling data such as male, female, or Democrat, or or a color of a window. These things are nominal scales because they cannot put in or changing their order doesn't make sense, right? Whether you have male, female, or female, male, or you have yellow, blue, brown, or brown, blue, yellow, it doesn't matter. However, data is in place in order, like let's say the height of the people or the weight of the people. That can make sense because you come from higher to lower or from heavier to lighter. That's ordinal scales. I suggest you to go to these pages 6 and 7 in your book and read about interval scale and ratio scale. You should know and try these exercises before you go to the video lesson 2. Let me go to the next set of slides. Some more nomenclature we need to use. Sample is a subset, we already said that, of the population. In the case of Limassol City I mentioned, the Limassol City was a population, but the Limassol City could become a sample if my population is a whole country, right? So if your population you are investigating is a whole country, then the city is just one sample. A variable, and of course, if you want to do a sampling of in a national level, you are not going to take only one city. In that case, you have to take proportional weighted citizens numbers from all cities, right? In order to have what we call a stratified sample. Variables, of course, is a characteristic of interest about each individual element of a population. So, for example, the student age at entrance into college, or the color of his hair, or his weight, height, etc., could be variables. So these are subjects of investigation, let's say, and then these are receiving values, and so these are variables. Data, the word data can be seen as singular and plural. If it's singular, then we're talking about one value from the set, and if it's plural, then it means it's a set of values. Okay? So then the word experiment is a planned activity. We know what is an experiment. So whenever you do an experiment, you measuring things, you collect data, then you're producing statistical data that you are able to analyze. A parameter and a statistic, of course, when we take measures of populations, then let's say the average of the citizens of Limassol, when Limassol was a population in our example earlier, then we symbolize the average with a Greek letter. If it's a sample and we take the average, let's say in a sample, then it's a statistic, and we use English letters. For example, for the mean, the average in a sample is X bar, while in the population is a parameter is the letter mu, the Greek letter mi. So in these cases, if you see these letters, you understand that if it's English characters, it's a sample that you need to use it. So let me erase this for now, and let me go to the next slide. Okay, an example, the frequency distribution. I take an example of 30 IQ scores. You know what is an IQ score. So these 30 numbers, we want to put them in the so-called group frequency distribution. Usually we try to make groups, as you can see here, these intervals in less than 10. And of course, in order to decide where to start, and you have to see what is your smallest number in your data. It can easily be seen to be 89, and the largest, it looks like it's 142. So I can start from scales starting around 80 to 150. It's about 70 points. So if I want scales of 10, let's say, length, that would be about 7 scales. So I have my 7 scales. In these scales, then what do? I go back to my data and I find where each number belongs to, in which interval, and I can use tallies to quickly find this. I have one number going into here. I have 3 numbers in this scale, in this interval, 7 in this. This is one way to symbolize 4 plus an incline, a tally to make a group of 5. So when I do this, I measure the number of IQ scores falling in each interval. These are called frequencies. The total must be, of course, 30, because it has to agree with the total number of data that I have. Okay, if you happen to find 29 or 31, means you missed something or you double counted one. These are called class frequencies. These are called the lowest and the upper are called class limits. So you have lower class limits and upper class limits. This is another language we'll be using. Then, of course, a class potentially contains scores between 89.5 and 90.1. This is the midpoint between the upper and the lower of consecutive classes. So this means the length of the interval is 10 points, as we will see later. So these are called boundaries or real limits or true limits, depending on what book you use as far as a language. So a class mark, sometimes we want to use one number to represent a whole class. What do we do in this case? We take the average between the 2 class limits, and that's 84.5. So sometimes we can use 84.5 to represent the class. And of course, we already mentioned the length of the class. Cumulative frequency is another measure we want to do sometimes. If we want to say, okay, we have our interval and the frequency, you are asked to say how many scores are 109 or less. Of course, you formulate this cumulative frequency distribution. You say how many are 89 or less, 1, how many 99 or less are 3. So if you answer 99 or less, it would be these 3 plus the 1 lower than that. That makes 4. So 109 or less will contain the 7 of this class plus the 3 of the previous and the 1 of the previous. 7 plus 3 plus 1 makes 11. In the same logic, we find the remaining cumulative frequency. I'm sure you understand this. And the last number here, remember, the last number has to be the total, the sum of the frequencies, always. And otherwise, you miss something or you made some mistake. And of course, you can think of computing the greater than. Greater than, if I ask you how many scores are 130 or more, it will have to be these 2 plus 1, right? 130 plus 1. So that the scores in this interval plus the one above it, because it's more. So 2 plus 1, 3. If I ask you how many scores are 120 or more, it would be 7 plus 2 plus 1, that makes 10. So you can easily find some annotation about this number 30, which is the sum of the frequencies. We will see symbols very soon. You should know that this is the sigma, the Greek letter sigma, which means sum of the frequencies equals 30. So this symbol is probably the first statistical symbol you see, sigma of f. You saw the x bar and the mu earlier, of course, but sigma of f means the sum of the frequencies equals to 30. So let me erase this for now. So this is more or less what we want to cover in the video lesson 1 of 15 minutes. Another way, I think we have 2 more minutes. Another way to present data is stem and leaf plots. This is easy, but this is useful sometimes because it retains original information. So in the interval 82, instead of saying I have 1 score, I put the number 9, indicating that this score is actually 89. In the next class, 90 to 99, I have 3, remember? So, but these were 90, 92, and 97. So if I make my plot like this, the stem and leaf plot, stem is the line and each number is a leaf, like a tree and a leaf. Looking at this distribution, graphic distribution, I can say what are the 3 numbers inside this class, inside this interval, 90, 92, 97. In the next one, it would be 100, 100, 100, 103, 105, 105, 107. So this kind of plots retains original information, while the previous one, I only knew how many scores there are. So sometimes it's useful to have this plot. Of course, keep in mind that nowadays we have softwares like SPSS, for example, to produce such plots and everything we need, as long as we know how to use it and we know what to ask. So as long as you have your data inside an entry spreadsheet, Excel, for example, you can always use software. But in secondary education, we probably not use such software, but I'm sure you can try if you want to. I think this is what we need, and I stop the sharing for these 15 minutes lesson, video lesson for Introduction to Statistics. I hope you have a taste of it already, but do the exercises we showed, and before you do the video lesson 2, and have fun with the numbers. Okay, see you next time.